Welcome to the Middleware Tech YouTube channel. In this series, you'll learn about inheritance using Python. All code examples used in the videos will be available on GitHub. Let's get started.
Inheritance, another oops concept using Python. That is the topic. Okay. So already told you what is inheritance. Now, so let me tell you a type of inheritance in Python. Type of inheritance. So as you know that we have different types of inheritance like single inheritance, multi-level, hierarchical, multiple, and hybrid. These are some of the different types of inheritance, right? So these different types of inheritance, how we can implement using Python, that we will understand using in a small example. So first one, we have single inheritance. Right. Second, we have multi-level inheritance. Okay. And then we have hierarchical inheritance. Okay. And then talked about multiple inheritance. And hybrid inheritance. So generally, right. So now we have to understand how these inheritance features will implement using Python. Okay, so we'll try to understand these things using some small code. Now the thing is that if I'm talking about this, inheritance is one of the oops concept. Now why I'll go for inheritance? What is the advantage? So main purpose of using inheritance is that if I already some code is there in the base class, then why I'm going to write in the derived class or child class, right? So what I'll do, I'll extend those code from the base class to my derived class. So what is the advantage? Advantage is nothing but I'm going to reuse the code that is already available in the base class. I'm not going to write the same code in the derived class once again. I want to reuse that code. So reusability as well as extension of functionality, this is the major advantage of inheritance. If I want to say why inheritance, right? So then we can say two major points like extension of functionality and reusability of code. Reusability of code. So these are the two major advantage of using inheritance. So let's understand it using a small. Let's first we'll talk about this multiple inheritance, single inheritance. So single inheritance is nothing but the inheritance between two objects. Okay. Nothing but the inheritance between two objects. Talked about single inheritance. Assume we have one of the object as shape and another object is circle. Okay, so I have one object shape, another object called circle, and I can create association like circle is this. Sorry. You can define like car is a vehicle. You can define like this car, and you can use one of the attribute called vehicle. So in case of single inheritance, we can say like car is a vehicle. Okay, or for the time being, assume this is a base class. Don't use the name, and this is a derived class. Okay, so we can define this inheritance as BB is a this class like this, right? Okay. So if I have to define this one, so I have a base class. So how to define base class using Python? We have class, so base class already we know, right? And inside this class, assume you are going to define in particular method. So how is the defined method? Method self, right? And print, we can define like is zip or this class. You can define like this, right? We have one method, fine. Similarly, you can define another one class. Okay, assume it is a derived class. So how I'm going to define the derived class in Python? So how we can do using this? If you write like this, that means is that B is a derived class or B is a child class, and B class will extend the functionality from A class. That is the meaning of this. B class will extend the functionality from A class. Fine. Right now here inside this class you can define another one method one I can define that have self. Fine. Now if you see this method, and here you can print some statement like this is circle class, right? Okay, sorry. What you can define here, right? Okay. Now we have implemented the inheritance using this in Python, right? So now I want to see that yes, it is working or not. It's working or not, right? So what I can do is that create an object of derived class like obj1 equal to create an object of this class, derived class, right? Now getting this object obj1, you can call this method. So this is a method, right? So if this class extend this class, so this method will also be available here, right? So method and method one both will be available here, correct? So this method should work as well as this method one should also work. Both should work. That's it. A single inheritance. This is single inheritance, right? So let me check it's working or not. Single inheritance demo. Control C and open this. Control V and just printing. The extra vector comes and that creates some problem. Class completed, right? And this is my derived class. and this is my derived class. And so just save it, file, save all. Okay, and save it as some single inheritance demo. Inheritance, single inheritance .py, and put it in a separate folder. Inside that, for class and object, I have used this folder. So for inheritance, you can write.
So we have to give class name .py, right?
No. It is not in case of Python. It's not mandatory that you have to use class name only in a file name. Not mandatory. You can use other name also. So in this class, I'm going to save inside this file. So it is not mandatory that I have to use the class name only. No. So that's why I'm using some other name. Define this class. Okay, inside this folder. So go inside this folder and just save it. Fine. So file save all, and just you have to implement some. This is another class, and inside this class, this is the method. Fine. So file save all, and then you have to print. So you can execute and check. Yes, it's working fine. So that means create an object of the child class. I can print base class method details also, and it's working, right? So this is called single inheritance because you're going to extend between two class, and it's working fine, right? Okay. So like this way, you'll find multi-level inheritance. How we're going to implement multiple level inheritance in Python. So same code we can implement in case of multi-level, because in case of multi-level inheritance, we have another level of class. So just see here, I'm going talking about multi-level inheritance. So in case of multi-level inheritance, more than two, if you are going to implement inheritance in more than two class, then it's said to be a multi-level inheritance. So if it is, then you can say here BB class, this class will extend the properties from this class, and you can write another one level, this one. So we can say here like CC class will extend the properties of BB class, and then this PB class will extend the properties of AA class. Okay, in that case we can say BB is AAA. This is the easy association you have defined between these two classes. Similarly, we can say this is a this. Multi-level inheritance means in the same level, if you are creating inheritance between more than two objects, then it comes as a multi-level. So if I want to implement the same functionality using this, so same things, we have to add another one class, right? So create another one class, Control C, create another one class. So just create it here, Control V, and the class name we can define here as this. That will extend the properties of this. And assume we have defined one method called method2, and this is a child class in assume you just provide the class, and this is also a child class, and that is this, right? This is how we can implement multi-level inheritance. And we have to check that how whether all the properties of base class is available in the derived class or not. To check it, you can create an object of this. So this one, and it has method 2, should have method 1, method 2, all those three. So you can write here obj1 dot method 2. Fine. So it's fine, noises. Just save it, file save, and save this file as a multi-level inheritance. Control C, and file save as. Now, if I want to create a new file, it's fine. Or so create a new file, noises like this. So file save as. I'm just saving this file as multi-level inheritance, multi-level inheritance .py. Okay, and define these methods. Then we have another one class, and inside this class we have one method, and we have the third class, and in this third class we have defined and picking an object, you're calling methods. Fine, so just save it. And just execute, and you can see it's working fine because this class can have access to all the methods of base class, right? So that multi-level inheritance is working fine using this, right? So it's a simple one, nothing, no complexity. Okay, now we have, and the next inheritance that we have, as you know, that is multiple inheritance. Next, can you hierarchical inheritance also? So let's talk about hierarchical first. Then come. So how we can define the hierarchical inheritance, as you know. Let's see, copy. Talk about this. So how we define hierarchical inheritance is that if we have a single base class and multiple derived class, then we define it as an hierarchical inheritance, single base class and multiple derived class. Right. So single base class and multiple derived class. Question is that how I'm going to implement these hierarchical inheritance in Python. So take this example. Assume we have one class shape, and we can have multiple derived class from shape. One is circle, can have a rectangle, right? It can have multiple derived class. So take this two itself, circle and rectangle. So if you any method is available inside the shape class, assume shape class has a particular method called area. So that method will be available to circle and rectangle both. Good examples of hierarchical inheritance. So how we can implement this one, right? So if you just write that code, just now you have done. First you have to create a shape class. Right, so first you have to create a shape class shape. I'm going to define the shape class. You can use area, and inside this area you can use self. Use the method right inside the shape class, and you can print something like print some statement inside this. This is a shape class. Okay. And then you can create another two class circle class circle. So circle extends it. So right, so how I can define in Python? In that case, you have to just define like this. Okay, so if it is, then inside this circle, you can define another one area method, def area one, or you can make a C area. Okay, method, and inside this print something. This is circle class. Okay, fine. Next, you can define another one class that is a rectangle class, because this will extend shape as well as rectangle is going to also save, right? So if it is like this, then you can define another one class rectangle, and this is going to extend shape. So inside this class, you can define another one method, rectangle area R. Okay. And self, fine. And here you can print something, print like something. This is rectangle area. Okay. So we have created this inheritance hierarchy. This type of inheritance hierarchy is called hierarchical inheritance. Okay. So let me check it is working or not. It will work, no issues. In that case, what we have to do is that we have to create an object of circle, right? So assume C is an object of circle. Okay, and using she, I have to call C area. Similarly, assume R is an object of rectangle, and using R, going to call R area. That's it. It should work fine, no issues. And both the derived class or child class should have access to the base class method area. So you can make it like C dot area as well as R dot area like this. Fine. Okay. So let's execute it. This is an examples of cycle inheritance. So create this class here. So it is only the things will come. The interesting thing will come when you talked about the multiple inheritance. And this is a normal flow that we use. Inheritance. Hi. So if you see this flow here, this is one class. This is the second class. Okay, and this is the third class. Okay. Now the three class completed. I'm creating an object of the first child. I'm creating an object. I'm calling the area method of that class as well as area method of the base class. An object for rectangle. Using this object, I'm calling the area method of this class as well as the area method of the base class. Save all. So they may find some problem with this. Will come because of copy paste. Some extra character came in between. This is shape class. File save all. So you can check where the problem. It's correct only. File save all. So copy once again. File save. Class def area self and print. This is shape area. Save all. And can execute, and it's working fine. Right. So both the class circle and rectangle can get and can have access to the method of the base class. It's very easy to understand. Nothing is there, right? Okay. Now the point, the interesting things will come in Python. We talked about multiple inheritance. So here actually, yes, please.
Yeah, I just want to ask, I'm sorry because I'm asking something out of the context question. Yes, I just want to curious about that. So are you going to teach us database connectivity and file handling?
Yes, we'll talk about database one or two examples we'll show with database connectivity as well as file handling. We'll show one example. Okay. See what will our focus is that today I'm going to focus on OOPS concept. Tomorrow we'll go with OOPS.
No, I'm not asking you to today. I'm just asking you in the overall course. Are you going to be just giving us some brief idea about this topic?
Yes, it is there. It is there.
I'm not just asking that today or tomorrow. Just anyway.
Okay, fine, nice.
Thank you.
Okay. Now, now here, okay, we're talking about where next inheritance you're talking about, that is multiple inheritance. This is the inheritance that in Python it is, they have tried to resolve a very good scenario. Just see here, please. They have make it, this interesting features is not there in Java also. I talked about multiple inheritance. If you see on Java itself, Java also does not support multiple inheritance. Okay, but in Python support the concept of multiple inheritance. This is one important difference you can find between Java and Python. Java using a normal class, they cannot resolve the concept of multiple inheritance using a normal class. But in Python, using a normal class, they can resolve the concept of multiple inheritance. So, so how they're going to implement the concept of multiple inheritance in using Python? So just see here. Multiple inheritance means what? I have more base class, right, and a single derived class, right? So this is multiple inheritance concept, right? We have more base class and a single derived class. So that means one derived class is going to extend the properties more than one class. So if this is the scenario, that scenario is not supported in Java. In Java, I cannot write this class will extend. In Java, generally we write the syntax like class EE extends this, comma, this, comma, this. So this concept is not supported in Java. I cannot write like this in Java. That's why we say that Java does not support the concept of multiple inheritance. But this multiple inheritance concept is resolved in Python very well. So just see here. So I'm just giving you the scenario. Assume you have one class. Okay, so take this scenario itself. You have one. What is the problem that Java cannot resolve, but Python can resolve? What is that problem? The problem is, assume this is a base class, and in this base class you have a particular method, MD1. Okay, fine. You have another one base class. You have another one base class mode, right? So I have another one base class, that is class this. And inside this class, we have another one method called MD2, right? Or MD1. Now, now, if I'm going to write like this, the derived class, assume my derived class is class E, and this class is going to extend the properties from this class and this class, right? Now the question is that in both the class we have same name method. In both the class we have same name method. So if we have same name method in the both the class, then which method will come? The method of this class or the method of this class? When we have same name method in both the base class, when I'm implementing multiple inheritance, That means the derived child class should extend A as well as extend B. So if this is the scenario, then which method will come? That is the ambiguity. So that ambiguity problem had no solution in Java using class. So that's why we say that Java does not support multiple inheritance. Using class, I'm talking about, right? Now that things get resolved in Python. That is very good scenario, right? So how Python resolved this ambiguity? Python support it, or Python resolve this ambiguity using the order of the class. Okay, how it is? Assume if both the class contain same method, then it will take which method? It will take the method who will be available in the left side of your declaration. Now here it is extending to class. So in the left side, which class is there? It will move left to right. The left side you have this class, so it will extend the method from this class. And then it will extend the method from this class. So which method it will come? This method will come. Because on the left side, you have this class. Similarly, if I'm not going to write like this, if I'm going to write like this, this extend like this. Then this class will extend both the class. But which method is going to come inside the data class? The class that will be available on the left side. So this class method will come in the right class, right? So this ambiguity problem actually resolved in Python in case of multiple inheritance using the order of the class. So one statement we can make here, like Python support multiple inheritance. Okay, Python support multiple inheritance using order of the class. Okay, it supports the concept of multiple inheritance using order of the class. Okay, fine. Now, so let me see it using a particular example. Just I have given theoretically. So let's understand the same thing using an example. Okay, so write one class. Write one class. First I'm writing let me write one class like class this is my base class A. Fine, this is my base class A. Right, inside this class I have one method called md1. Fine, so define one method. Already you know how to define method, right? df md1, and you can use a self and write some statement inside this like print, and I can add like this is inside the A class. Okay, now next I have another one class, this class, right? So class written B. If you're writing this class, then we should define one method inside this class using def md1, assume it is also the same name, and self, And you can write one statement like this is inside class. Okay. This is inside class. Fine. Okay. Now I'm going to define the last class. Okay. Child class in case of multiple inheritance. Okay. So class is this one, and this class is going to extend both the class AA and this. Now I can write something. Which class it is going to call? I can write something here. Fine, no issues. If I don't want to write any code, you can use pass to work. Now what I want to do is that I create an object of this class. I want to see that which method came. A method from this it came, or method from this came. Right. So I can create an object of this. It's like you can create an object obj equal to this. Okay. And from there you can write obj dot MD1. Save it. Right. Okay. Fine, right? Okay. Now we'll see that which method is coming. It's a method from this class, or it's a method from this class, right? So let's see this. Control C, and let us create another one file. Control V, and save this as an multiple inheritance .py. So file save as. So you can use it as multiple inheritance and .py. And okay. Now this is my first class, base class. This is my second base class. Fine. Okay. And this is my third base class. Okay. And when I came outside the class, I've created an object of last class. So that is this. In this object, I'm calling this method MD1. We'll see that this method is from which class? This class or this class, right? Okay. So file save all and just execute. And you can see here it is calling MD1 method of AA class, because A is in the left side. I already told you that when both the base class, not only one class, you can have multiple base class that have same method, then it will follow the order of the class from left side to right side. So the left side we have AA class. That's why actually got the method from that class. So you can change this order. If you change this order, you will find it's going to call the method from this class. Just check it, file, save all, and execute. And you can see here it's calling the method of this class, because this class is in the left side, right? So this is how Python support the concept of multiple inheritance. Okay. Between, yes, please.
Sorry to interrupt. Can you tell me what is this pass about again, if you don't mind?
Okay. Pass means if I don't want to write any code, inside a class, then using this pass statement, you can execute that. If I'm not going to write any code, I can keep it blank, right? But But if you execute this code, you can see it's giving some error. I don't want to write some code, then you cannot make it blank.
Okay, it's kind of
Okay.
end, like end.
Yeah, I do not write any code. I want to keep this class as an empty itself. I do not write any code. So if you write like this, it will give an error. So just write this statement, then you can compile and run. So most of the scenario, if you don't want to execute that line of code, you can use pass. Then code.
Got it. Thank you.
So this is a small examples of multiple inheritance that are supported by Python. It is a very good features how it's implemented here, and this feature is not there in Java. So that is one of the very good scenario from our discussion point of view. Right now, in Java, it's about multiple inheritance. In that case, you have to use interface. Using interface, it supports the concept of multiple inheritance. But in normal class, yeah.
Amitabh?
Yes, please.
Yeah, what is the point in mentioning, multiple inheritance? Why? Because it is based on priority only. Order of method only, right? So I guess this is not a feature.
No. Multiple inheritance. Multiple inheritance means.
See, here we have
I got your
taken
point.
only 2 classes, right? Suppose if we have taken 10 classes or 15 classes, so instead of creating that suppose if we take 10 classes, if we give 10 classes in class E, only left only one class will take, right?
I got your point. So just see there, number 2. We are saying it is a multiple inheritance because this class is going to extend the features from both the classes, both the base classes. That's why I'm saying it as a multiple inheritance, because this is a derived class that is going to get the features from both the classes. Now the problem or ambiguity will come into picture if both the class contain same name method. Multiple inheritance means we have multiple base class, and I am creating a derived class. So when I'm creating a derived class, my class should reuse the code that is available in already created classes by the developer. Other 10 classes, already those codes are there. I can extend those code from those classes to my class. So that is the multiple inheritance. But the point is that if same method is available in some of the classes, then this order will be followed and extending those methods. That is the scenario. So this order is based upon the condition when same name method will be available in more than one class. Then only this order will be followed. So that is the scenario only. So it is multiple inheritance.
Okay.
Now here, related to this, in Python, they have created a very good algorithm. That algorithm is called MRO. We use this, the things that just now I told you, the same things. If there is an inheritance hierarchy, then how it will be followed. So related to this order of execution of class in Python, they came with an algorithm. Name of this algorithm is MRO. MRO full name is Method Resolution Order. Method Resolution Order, MRO. So this method resolution, what is this method resolution order? that is being followed. So just see, we'll understand this same concept, but it will be in some more inheritance hierarchy. So as we do in Java, when you write any class in Java, by default it will extend one class called object class in Java. Similarly, in Python also, we have a concept of object class. Any class you write in Python, by default you will extend one class that is called object class. So in your inheritance hierarchy, for any class, top level class is an object class. Python itself. Python also we have this feature. So assume A is a class that will extend from this class, right? Now you have two derived class from A class. Okay, you have two derived class from A class. First class is assume it is B. Second class is assume it is C. Okay, so you can use some space if you want, right? So if you see this, I have two derived class, B and C from A, and A extends from object. And assume I have another one class called D class, and D class will extend from B and C. If this is the inheritance scenario, then when you have written D extends B and C, so how they will execute. So just now I told you, right? Method resolution order, how D will extend the features. So if you see here, D should extend from C, D should extend from A. So object properties should come inside A class properties should come inside B class properties should inside D class. Similarly, A class object properties should come A class properties should come in the C class properties should come in the D class. So the question is that what is the method resolution order when you have inheritance hierarchy? So just now I told you what is the method resolution order in case of inheritance hierarchy in Python. That is the point. So method resolution order is saying that, so I'm just writing it proper way. I think it's much more better. It is like any specified attribute or method is searched first in the current class, and if not available inside this current class, or if not found, then the search will continue into parent class in depth first and left to right fashion, right? So this is MRO. What is this MRO is saying? Just let me write it first. So any specified attribute, this is actually the standard definition, that's why I'm writing it proper language. Any specified attribute or method is searched first in the current class, So if not found, then the search will continue into parent class, in our examples we have this parent class in left to right fashion. left to right fashion. So that is searching in this way is called MRO. Searching in this way is called MRO. So I want to know what is the MRO for A class. Here I have total how many classes there? A class, B class, C class, and D class. Total 4 classes there, right? I want to know what is the MRO for method resolution order for A class. So if it is, then what I want to say, I want to know MRO of A. What is the MRO for A class? First, it will search in this current class, this attribute. If it is not available, then it is going to search in object class, right? Yes. Now, what is the MRO of B class? What it will do? First, B class, right? So first it will search the current class, then it will search in A class, then it will search in the object class based on this MRO order, right? So first it will search in the B class, search in the A class, then object class. Okay. Now what is the MRO of C class? Right. So MRO of C. What it will do? First it will search A class, then it will search. Sorry, first it will search in the C class. It will search in the A class, and then it will search in the object class. Right. Similarly, you can get the MRO for D class. MRO of D. What it will do? First, it will search in the D class. Now, what is the flow? Then it will use left to right. That means then B. If it is not there in the B, then it will check C. Right? Then it will go to the parent A. Then it will go to the object. This is the flow. Now see, I want to see that. I want to see that. Yes, this is the flow. I want to see that, right? So just write this code. Write this code here. You can see that flow. It will show you. What I want to say, like I'm creating a class. Key. Assume. Okay, and assume some method is there inside this class. So I'm following this order, right? To follow this class itself. Who is the base class? Base class is A. So base class is A. And inside this base class, you have a particular method. M1 self. Okay, and let's write print and write some statement like this is a parent method is a parent thing. Okay, method. Now what I want to do is you can create a class with the derived class. Just here please, derived class is B. So class B extends A. Right, if you see this inheritance hierarchy, class B should extend A. Fine. Now you can use def m2 self and write something inside this as print. This is a class method. You can write here. You can write This is B class method. Okay. Now A and B class we have talked about. A, B. Now I'm talking about C class, right? So C should extend A. Okay. So class C, it should also extend A. Okay. Now def M3 self and print. We can write this is a C class method. Is C class method. Fine. Okay. Now just see this inheritance hierarchy. The D class that is going to extend B. Not there, then it will go to C. So you can write D is extending B and C. D is extending B and C, right? Okay. So class D should extend B and C. Fine. Okay. Now you have to define a method M4 using self, and inside this I have to use print, and right here this is a D class method. This is D class method. Now what we have to know is that just now I told you that what is the MRO of a particular class, right? So that I want to check whatever I've written is correct or not, right? I want to check. So let me check what is the MRO for each and every class, right? So how I can check? I can create an object, a particular.
Yeah, sorry to disturb you.
Yes, please.
For class D, we can mention B, C, comma A as well, right?
No, it is a multiple inheritance, no? So this will be like this because A property is coming inside B and this property is coming inside C. And D is extending B and C.
Okay, got it.
Not A.
Yeah.
Actually, I'm not writing properly here because it's in a notepad. That's why it's not coming actual. Fine. Okay. Now here I have to create an object of a particular class. So I can write here print. I want to print the MRO. Okay. So which class MRO? I want to print the MRO of A class. So A dot MRO. Okay, so let me check it's working or not. Save it, file save, and just execute. Okay, save it as MRO.py. Okay, now just execute. So just see here, it will give you the MRO. First A class, then object class. Okay, now get for the B class and execute. See here, first B class, then A class, then object class. Now use it for C class. So you can use here C class, A class, and object class. Now I want to check it for D class, right? So as I told you, just use it for D class. Now see the flow. First D class, then it will check first B, then C. First B class, then C class, then A, then object class. Right. So this is in a particular algorithm, message resolution order, when you have multiple inheritance hierarchy. In that case, how an specified method is searched in your inheritance hierarchy. And a very good and interesting algorithm that they've given in Python, but this type of algorithm you will not get in Java. So since Python came long back before Java, 5 years back it came, right? So that's it. There's good features in Python. Fine. Okay. So another important features we talked about in this inheritance. Another one important features we talked about, that is called super. The last features in this concept, super. Let's talk about this. Is another important point. You have to use it in multiple location. You have to use this.
Yeah, Amitabh.
Yes, please.
Yeah, did you finish this MRO?
Yes, just now we talked about, no?
Yeah, but the thing is that I'm unable to understand the last few steps. That's why I'm asking.
Okay. In the last step, what he talked about is like, just see here. Let me see once again. Here in the last step, that means D class is going to extend B and C. Fine. So
Yeah.
the point is that how D class is going to extend, because it is extending more than one classes. So how D class is going to extend a particular method from its base classes. Now in this example, I have only one inheritance hierarchy. Similarly, you can have 5 or 6 inheritance hierarchy. Now how it is going to get it? So for that MRO, we have just executed, just see here, just written d.mro. When I'm writing d.mro, it is showing the flow. First, it will check in the D class, then it will check in the B class, because the flow it is showing here itself, C class. So the flow just now I talked about, it'll check in the D class, then B class, not there, then it will check in the C class, then it will do over the immediate base class.
Okay, you actually printed the flow of the MRO, right?
Yes, I printed the flow of the MRO, writing like this.
Actually, I thought that you will make a duplicate of a method in all the classes and then you will search. So anyway,
No,
thank you.
No. Just trying to show the flow how it actually.
Yeah, exactly. Perfect. Thank you.
Okay, fine. Now here, next an important property, that is super. Let me talk about some points on this super. It's very good, important point. Now already I told you that.
Sorry to disturb, Amitabh. It's
Yes,
a hybrid inheritance also there, right?
Okay. Hybrid inheritance is said to be as a combinations of all the inheritance. It is not a particular concept like this is called hybrid, not like that. Hybrid inheritance is defined as, you cannot say that this inheritance property is hybrid. So if you find, find multiple, hierarchical, multi-level, single. Yes, how I'm going to define this hybrid inheritance is actually combinations of all the inheritance. So if you have, if in your application, okay, in your application, if you are using single inheritance, if you are using multi-level inheritance, you are using multiple inheritance. So combinations of all the inheritance is called hybrid. So you can write like this, hybrid equal to, in your code, you have single inheritance. You have a multi-level inheritance. Level inheritance. Just now I talked about you have multiple inheritance. Then you have hierarchical inheritance. You'll get some code like that. So if you have all those 4 in your code, then we say that these is a hybrid inheritance. So there is no separate definition of hybrid. Combinations of all the inheritance is called hybrid. If it is available in your code, then you can say that code is based on hybrid inheritance, like that only.
Okay.
Now, okay, and so let's move with the next part, that is about super.
Sorry, Amit.
Yes,
Actually,
please.
I have doubt in the multiply inheritance.
Multiple.
So multiply. This is the 4th inheritance we are discussing,
Yeah.
right?
Yes, please.
So when you are creating the same name method, and you are calling when you are calling, it's automatically called for the which you are created the first, the left side to right side.
Yes.
The same method, right? So
Eh,
so why is not going to the next, means left to right? There are two same method is two is there, only is printing this name is AA class. Why is not printing the inside the BB class also? Can you open that program? I can show that
Okay.
you
Okay.
saved already. Yeah.
Is it this one? No.
Not this one, the old back one.
File multiple. Okay.
Yes.
Okay.
So when you are executing, it's can you execute as of now?
Okay.
It's showing only the first is because you are mentioned the BB, because that is a your left side method.
Okay.
Why is not printing to the AA method inside that
Okay.
AA?
Okay. 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 Now here, print. I'm going to write here EE dot MRO. Now just execute. Save this file. Save. Execute. So MRO, as per MRO, this is saying that first it will check. First it will check that method MD1. What MRO is saying? MRO is saying that I'm calling MD1, right? Okay.
Right.
So MRO will check first. It is there in the EE class. It is not there in the EE class. Fine. Now for it will check. It is there in the BB class. Yes, it is there in the BB class. So when MD1 it will got in the BB class, so then it will not go into the next.
So this is the disadvantage, means.
This is the searching format. If I'm going to search a particular
No, actually in the, if you're compared to the always in Java, so I'm also comparing with the Java. When the Java is in multiply, why is not working? Because they are compiling the whole program at a time. Like a JVM is compiling at a time. So that's the reason he confused which method I'm calling, because both our method is same name. So that's the reason is drawback in the Java. But in the, the Python, they are compiling one by one line. So it will compile the first line and it executed, but the it's need to execute the second line also, because it's compiling line by line. So this is maybe the disadvantage, or the is only printing the first line only in the multiply inheritance I'm talking about.
Okay. No. Okay. Now, first point is that what we are going to do is that I'm going to call a particular method, MD1.
Yes.
So when I'm calling this method, the thing is that on both the base class, I have same name method. This will.
Yes.
The scenario is that both the base class have same name method. Now the question is that which method should come in the derived class. So that solution, for that particular solution, MRO is saying that it will follow from left to right. That MRO is saying. So for MRO, as per MRO, first it will check in the E class. So it is there or not? It is not there.
Yeah, what happens if you just change it to the order? Means instead of BB comma A, we do the AA comma BB. In that case, I think it will print the AA class, right?
Yes. It will follow always this order to print that particular method or to search that particular method, and based on that, it is going to execute first A, then BB. I print this one. This is how it is going to search that particular method in the top level inheritance hierarchy when same name method is available in more than one class in the inheritance hierarchy. Based on this order, how you have given. That is only. And in this example, the order I have given first A, then BB, because both are base class. So based on the order provided, it is going to search. That is the only MRO. But that was not there in Java, because as you know that it is being resolved with interface implementation. So using class itself in Python, they follow the MRO order to call that particular method, same name method from base class. Anything else you want to add?
Yeah, that is okay. But if you are suppose you will write the more methods like a BCC or DD class, then it will only execute only the AA, the first which we are written in the left side. That will
Yes.
execute.
Yes, correct.
Okay.
Because all the method name is same.
Yeah, yeah, main, yeah, but yeah.
I got your point. You're not getting satisfied. That's why you'll say that no, my Java interface implement is much more better better than this.
No, the Java is the, if you're compared with the Python or Java, because we are studying only the OOPS concept, so all are similar. You are not denied the Python is good and the Java is good, but as of now, every concept, if you are talking the constructor, you are talking the overloading, means is Python also not in overloading, but the other like a inheritance, all are same, which is the in Java also. But here only the little bit, only the code difference, like you can't import. When I am returning the Java program, so first line I always return import.io, input output, so is not there. So because only for the reduce the codes, nothing else. I think is all concept also same, everything is same till now. After that I don't know what is going on from
There
tomorrow
is some
onwards.
there is some import concept also is there. I've not yet used, that's why we'll use import and some of the when you come to thread application, you have to import. When you come to some package on time, you have to import. So we'll talk about it on the next.
And why we are focusing only on ops, why we are not focusing the procedure that
yes I'm following this format. If you can see here, first I'm just moving like this, where it is. Yeah, now I've moved with this part is done. Now I'm moving with this part, right? Now this is done now after some time, and then I'll go with this is a complete procedure part, this part.
Okay.
And here we'll find complete procedure for these things, all procedures. You'll get some OOPS concept in thread also, because before moving into those things, let me complete this part, then anything I can add, it will be clear.
Okay.
Okay, so let me complete the last part on this OOPS inheritance part, then we'll go with small hands-on. Okay, sure. Okay, now here in the super is used in OOPS concept of inheritance. So the main purpose of the super is nothing but calling the base class very constructor as well as method. So let me understand this super using an example before saying anything else on super. Let me understand one example of why I'm going to use this. Let me understand using an example, then I'm going to write why, how all the theoretical part. Let me understand why the need came for this. So assume I have one class. This is my base class. So it is also to some extent same like Java itself. So now here, this is my base class. So inside this base class, I want to define one constructor. Fine. So define one constructor. In it, define one constructor. It's a default constructor. Oh, I want to use a parameterized constructor. It's fine. No, you can use parameterized constructor a comma x comma y. So inside parameters constructor, you want to initialize some variable self dot x equal or self dot assume. It's a local variable actually. I don't know the same name. I want to use slightly different maybe. Self dot x equal to a and self dot y equal to b. That's it. So this constructor is initializing x and y for this class A. Fine. Okay. Now I want to create. Then I want to print about the variable value. Fine. So print self.x, and you can use comma. You can use no issues. If you want to print like this, it's fine. No issues. Self.y. And okay. Now I have another one class. I have another one class. This is an derived class. Okay, so this is my derived class. This class is going to extend this class, class. And this is a derived class. So in the derived class, I have three instance variable. Here I am 2 instance variable x and y. In the derived class, I have 3 instance variable def init. Okay, and self comma a comma b comma c. I have 3 instance variable. So this 3 instance variable I should initialize there. Okay, self dot x equal to a. Similarly, you can use self dot y equal to b and self dot z equal to c. So this class constructor is going to initialize 3 instance variable inside the class. Okay, fine. And this b is going to extend a class. Fine. Now what I want to do is that I want to create an object of this derived class. Okay, obj equal to bb. Okay, an object of derived class. I'm getting an object of this derived class and using this which object I'm going to create, getting an object of this class, right? So the constructor should have 3 variables. Okay, so 20, 30, 40. Fine. And creating an object. Now creating when you're creating this object, right? So it should call this constructor, right? And it should print all the variable value when it's calling this constructor. Control C, Control V, X, Y, and Z. Class the self dot Z. So if you execute this, it should work. This should not have any error. Let me check it is working or not. There is no super. Just I'm going to execute this code. Let me check it is working or not first. Okay. So file save and make it here as not used still now. Just the name. Okay. Now here. The 3 argument inside this. Save. Okay. Now here. Right now, this is the first constructor, and you can, okay, you're going to define the constructor, so you can use colon. You're going to define the constructor, you're going to colon. And if I'm going to execute, it should work. There should not have any error, and it is working fine. Now, what is the problem with this code? If I want to execute it like this, what is the problem? Now here we are going to use only 2 instance variable, and this 2 instance variable is available in the base class as well as in derived class. What is the problem with this? Problem is that if you see this code you are repeating from base class to derived class. Now it is here you have only 2 instance variable. Now, after some time, when you're going to work on a particular project, you may find that in the base class you have 40 instance variable, and you're going to reinitialize all the 40 instance variable from base class to the derived class. Okay, so the thing is that we are not implementing reusability. I'm going to write the same code into the base class and derived class. That is the problem. Same code I have is there in the base class as well as in derived class. I should reuse the code, right? That means if you have 40 instance variable initialization in the base class, same 40 instance variable initialization you are repeating in the derived class. So that is the problem. So how I can resolve this? How I can reuse the code that is available in the base class? That we do with the help of super. So what I'll do here, super dot you have to call the base class constructor using super dot. You have to call the base class constructor. So what is the base class constructor? This one. Okay. So call base class constructor. Init. Have 2 arguments, right? Base class constructor have 2 arguments, right? Fine. So see, you're already initializing here A, comma B. If you write it, then I'm going to write. I'm not going to write 2 lines here. So using this, I'm going to optimize 1 line. Not only that, if you have 40 variable initialization, using this single line, you're going to optimize 40 lines of code, right? What it is going to do? Using this, you're going to use base class constructor to initialize instance variable for your derived class. So you're reusing the code of your base class constructor to do the initialization of instance variable of your derived class, right? So just write this code. If you write this code here, so just write this code here. Here, I'm not going to write this 2 line. Okay, I'm not going to write this line as well as this line. Without writing that, I'm going to use a single line using super dot. Right, when I'm using the single line, then it is going to call the base class constructor and do the initialization for your instance variable for your object. See how it is working? Just save it, file save, and execute it. So if you execute, you can see here, if you are going to hit an object, it is going to call this constructor. So when it is going to call this constructor, then you're using super dot this. That means the control is moving to this constructor, and first it's printed A and B, 20 and 30. Right? Then the control came and this constructor, and it's going to print all the 3 values once again, 20, 40, 30, and 40. So what we have done here is that I don't want to write the code that is already there in the base class and reuse the base class constructor code. So to reuse base class constructor, we to call base class constructor, we use super. So if I want to use super, it is used to call base class constructor. That is one point. Now base class constructor is going to call, but what is the advantage? Advantage is that now it is for 2 instance variable. Can think of 40 instance variable. You're going to reuse the code that is already there in the base class. So advantage is reusability. Reusability, that is the advantage, right? And not only that, you can call a base class constructor, you can call base class method also. Okay, you can call base class method also. Okay, so if you want to call base class method, that you can call constructor and method. Right? Okay. Now, right? Okay. So that is the purpose of using this super, but there is some difference of super from Java to Python. There is some difference. So what is the difference? Now, if you think about Java, using super, you can call always immediate parent method or constructor, right? In Java, you can call constructor or method of your immediate parent class. You cannot call if I have another class in the inheritance hierarchy, you cannot call that class method and constructor, right? Using super. So you in Java, using super, you can call the constructor and method for your immediate base class. But it is not in case of Python. In case of Python, it will be, you can call for any class in the hierarchy. It is not immediate class. In case of Python, using super, you can call any class in the hierarchy, in your inheritance hierarchy. Okay, so just see, let's see with an example. We'll go into depth, no issues. So what I'm saying is that I'm talking about this super in case of Python. That is not there in Java. That another one features you're talking about here. Just see here, please. Using a code base, right? Better write using a code, it will help. So assume you have one class. This is your class, base class. And in this base class, you have one method. F M1 and this method.
Yeah, Amita, one thing. You are saying that we can call any method with a super, right?
Yes, any method in the inheritance hierarchy.
Yeah, inheritance hierarchy. Okay, right.
Yeah.
But can it be? Is it applicable for the constructor as well?
No. It is available only for method, not for constructor. It's for method.
Because the last example you have shown that is for the constructor. So
that is for immediate.
Yeah, exactly. That is why I'm saying that if you want to call the constructor, that will call the immediate base class.
We can always call. In case only for method. Any method in the inheritance hierarchy we can call using super. So that I'm.
Yeah, exactly. But not the constructor.
Not the constructor.
Yeah. Okay. Thank you.
Okay. So this is my class, and inside this class, I'm writing one print method. And in this print method, write something like a class. And one class is there, S class. Now I'm going to define another one derived class, that B extend A. Okay, so class B, that's going to extend A. Okay, and assume you have one method inside this class, and if M1, okay, self, and assume it written A class method, assume it is written B, and print B class method. So B class. Now I'm show another inheritance hierarchy here. My base class is C, and that's going to extend B, right? And in this, I can define another one method. Assume self and print like C class method. Now I want to use okay, if you want to make it D class, that also you can say. Assume you have one class D, so in C, and right, and definition, I'm going to define another method called M1 using self, and here I'm going to print something. Now see here, here. Now already I told you that using super, I can call the immediate class method using super, immediate class method. Now I want to call how I can call, let's see, get an object of D, like small d equal to get an object of D, fine, and then you can write D dot M1. And so if I'm going to call D dot M1, so which M1 are you going to call? Assume you have something here, print D class method. Now here, if I'm printing an object of D and I'm calling M1, so it will always give the priority for my current class. The M1 is also available from the base classes itself. So when I'm calling t.m1, it will always give the priority for your current class. If you don't have any method in the current class, if you don't have any methods, in the current class, then it will going to give the priority for this class. Let me execute, then it will be clear. Control C, save it as demo 1. Okay, so save it as again, I have to do the indentation here. This is one method inside class.
So it follows from bottom to top approach, right?
Yes, I'll show you. I'll show you. Just 1 minute, please. This is yes, it is multi-level inheritance you're talking about here. And we have four class in the inheritance hierarchy. Then I'm getting the object of D, and then I'm calling d.m1. So already D class contain this M1 method. So file, save, and make it here as super demo1. execute. D class method is going to call. Because I'm calling d.m1, it is giving the priority to this class. If it is not there, assume in the D class there is no method is there, pass. Then source. Okay, now here, assuming there is no method inside this class. So file save and execute. It is giving the priority for the C class. Fine. Now, if I'm going to use super, dot meth m1, so here assume I'm going to write here, assume I'm going to here. This is one method, and we want to call the base class method. So how to call base class method? Here I can call super dot m1, the base class method. Right now, assume this is an m2 method. File save. Assume this one m2 method. File save. So if I'm calling m2, so this m2 is going to, if I'm using super.m1, if I'm using super.m1 self or m1 itself, assume using super, file save. What I'm going to do, I'm going to call, if I'm writing super.m1, it is going to call the immediate base class method. Let's execute. C class method called. That means using the super, I'm going to call immediate base class method. Question is that is supported in Java also. Now the question is that what about this? I want to get M1 method of this B class. Can I get it? I want to get the M1 method of A class. Can I get it? That is the question. Using super, we should get immediate base class method. Yes, I'm getting immediate base class method when I'm using super.m1. It is working fine, no issues. The question is that can I get B class M1 method? Can I get A class M1 method? It was not possible in Java. We can't get. But in Python, it is possible. In your inheritance hierarchy, you can get where same name method is available in the different class. We can get the method of B as well as the method that is defined inside A in Python. Okay, so how assume I want to get the method M1 method of B. I want to get the M1 method of B. I want to get the M1 method of B. Then what I have to do? Right? So what I have to do is I have to get M1 method of B. So what I have to do? B is a superclass of which class? C class. B is a superclass of which class? C class. So I have to write super of super of C. Super of C, comma, self. That's it. Just execute. File save and execute it. Super of C dot self. Sorry, super of C. Okay, I have to call the method dot m1. Let's save it. File save and execute. Yes, it's calling the B class method. It's calling the B class M1 method, right? I want to call the A class M1 method. So then I have to go AO is a super of B class. So I have to write super of B, comma self M1. Then it will call A class M1 method. So this is one of the things that is not there in Java. in your inheritance hierarchy, using super, I can call any one of the classes method, not that I can call only the immediate base class method. I can call any class method in the inheritance hierarchy using super and Python. Whereas in Java, we can call only immediate base class method. That is the difference. Fine. Anything else you want to add? Okay. So what I'll do next is that we talked about lots of things here. We have lots of things also. Let it not to go much more on this. So what I'll do is that we talked about an inheritance super, how super is working using constructor as well as method. What is MRO, right? And then all the different types of inheritance we talk about, right? That is inheritance as an oops. We talked about the object relationship, easy and hazy, and how we can implement that easy using Python, right? So we have gone with